Good morning, Townview. So we're going to be talking about the average atomic mass. So everybody grab your journals, top of your page. We're going to write average atomic mass. The notes are going to be very short. Let's go ahead and get to it. So first thing I'm going to have you guys do is we're going to write the definition of average atomic mass. So the average mass of all naturally occurring isotopes. So can anyone tell me what a naturally occurring isotope is? What is a naturally occurring isotope? Okay, so what's the alternative to a naturally occurring isotope? What is it? I heard the word unnatural. Sure, there's another one. Artificial, good. Synthetic. So the average atomic mass is going to be the mass of all naturally occurring isotopes. So what's excluded in that scenario? Let's take a look at the periodic table up here. So right there we got lithium. Lithium has 3 protons. It's got a mass number of 7, which means it's got 4 neutrons. If we were to add neutrons to it, we could bombard it with neutrons, and we could change the mass of our lithium. We could create lithium-8. And it'll have more neutrons than lithium-7, which is the most common isotope of lithium. But in that scenario, do we take the mass of that lithium and include it in the average atomic mass? Yes or no? Why not? Is that a naturally occurring isotope of lithium? No, it's not. So only naturally occurring isotopes, artificial isotopes are not included. Now let's move back a little bit. All right, so we should all have this in our journal. Let's move on from here. Don't worry about this. Don't worry about this. We already talked about it. All right, so now we're going to discuss how to write these isotopes. So writing isotopes, you've already seen this on your last assignment. So the Unit 3 on positive physics, you worked with this stuff, but you didn't know what it was. So today we're going to discuss it. So first we have nuclear notation. So nuclear notation is this right here, which you guys saw on your last assignment. In nuclear notation, you're going to see your element symbol, and then you're going to have your atomic number at the bottom, and then you're going to have your mass number at the top. So the reason y'all didn't have any trouble with it is because, do I need to tell you which one of these two is the atomic number? Yes or no? Why not? All right, so the smaller one's always the atomic number. Why is that? The atomic number tells us what? It tells us just the protons. What does the mass number tell us? Protons plus neutrons. So I don't got to label them for you. You should be able to figure it out pretty easily. So the smaller number, that's your atomic number. The bigger number, that's your atomic mass. And you could figure out your number of neutrons by using those two numbers. All right, so next up we have hyphen notation. And hyphen notation is going to be your element name. Then you get a hyphen, and then you get the mass. So why is it that I give you the mass? Am I giving you any valuable information if I say U92? Yes or no? You sure? Is U92 giving you any valuable information? But aren't you able to figure that out on your own? So if I say uranium, how many protons do you have? So if I say uranium, you could just look at the periodic table. Everybody look at my table. How many protons in uranium? 92. So if I say U92, am I giving you any valuable information? No, I'm not. But if I say U235, am I giving you valuable information? Yes, I am. Because there's multiple isotopes of uranium. There's uranium-233, 234, 235, 236, 237, 238. And when I say uranium-235, you know exactly what isotope I'm talking about. So you're going to see hyphen notation a lot, and you're just going to need to know that this is the mass number. Now, if I wanted to figure out how many neutrons I have, can I figure it out using only this information? Yes or no? Is this enough information to figure out how many neutrons I have? Are you sure? It is. So we have 235 as our mass number. How many protons do we have? 92. So we just got to subtract 92, and we can figure out how many neutrons we have. Any questions on hyphen notation? So you don't need to know the names of these. I just wanted to break them down because you're going to see them over and over, and I just wanted to make sure you knew exactly what you were looking at. All right, let's move on. Next up, we have isotopes. First thing we're going to do is we're going to define the word isotope. So isotopes are going to be atoms of the same element that have different mass numbers. Go ahead and write that down, and then we'll discuss. All right, so let's look over here. So atoms of the same element. So if they're the same element, what's the one thing we know they have in common? If they're the same element, what do we know that they have in common? All right, protons, good. So if they're the same element, then we know we're looking at, they have the same number of protons. Examples being, so C12, C13, and C14. All of these are carbon. They all have 6 protons. So all isotopes of the same element are going to have the same number of protons. They are going to have a different mass number, though. So if they have a different mass number, what's going to be different? One more time. All right, neutrons is correct. So this statement, you don't need to write it. It's a very valuable statement, but everything that's here is actually written right there. So what does this mean? It means that protons are going to be the same and number of neutrons is going to be different for all of our isotopes. So let's look over here at this example that I got. So carbon, we know, has 6 protons. So that has 6 protons, that has 6 protons, and that has 6 protons. How many neutrons are in carbon-12? 6 neutrons. How many are in carbon-13? 7 neutrons, and then 14? 8 neutrons. So they have the same number of protons, different number of neutrons in isotopes. Any question on isotopes? All right, let's go ahead and move on. Don't worry about this. All right, so back to our formula over here. So we already defined average atomic mass. Now we're going to write out the formula. The formula is going to be mass times abundance plus mass times abundance plus mass times abundance plus ... What does ... mean? All right, this formula, it continues based on how many isotopes you have. Some elements have only 2 isotopes. In the case where you only have 2 isotopes, you're only going to use this much of the formula. But some elements have 5. In that case, what are you going to do? You're just going to keep going. Plus mass times abundance, plus mass times abundance. Now, the biggest mistake that I see students make with this formula is they forget the plus. So make sure that your pluses are in there. If you don't include the plus, you're going to end up multiplying, and your answer is going to be very, very wrong. So I'm going to give you all a little bit to write out the formula, and then we'll do some practice. All right, so let's go ahead and do some practice. But before we do our practice, one thing I wanted to point out. So your mass is just going to be your mass number, and your abundance is going to be a percentage. So our percentage, I'm just going to give you all some random ones. So let's say 90, 5, and 5, and then all of these are percentages. So can anyone tell me why we're dividing by 100? Why are we dividing by 100? So what do you have to do to get the percentages? To get a percentage, what do you got to do? What is it? Say it again. Well, no, because we already have a percentage. I'm wondering, how do you get the percentage? So think about any formula you know to get a percentage. What do you got to do to get a percentage? Y'all don't remember? All right, so let me show you an example. So 1 divided by 2 is equal to what? All right, so it's equal to 0.5. How do I turn this into a percentage? You do move the decimal, but you're multiplying by something. What are you multiplying by? What is it? Not 1. All right, so to get a percentage, Shh. To get a percentage, you multiply by 100. I guess y'all just not there in math yet. So you multiply by 100, 0.5 turns into what? It's going to turn into 50%. So, shh. So all of these numbers, all of these percentages, they've already been multiplied by 100. So how do we get rid of that? What do we do? We're going to divide by 100. So that's what's going on here. Because students always ask, why are we dividing by 100? It's to get rid of these percentages. So let's go ahead and do some practice. So I don't want you to worry about this part right here. I just want you to plug in the masses that that you have over here. So silicon 28 has a mass of 28, mass of 29, mass of 30, and then here's our abundances. So go ahead, plug this into your, actually before you plug into the calculator, I want you to write this one out in your journal. This is the only one I'm going to make you write. So go ahead, write it out, and then see if you can solve it. All right, so let's go ahead and talk about this one real quick. So I went ahead and filled out the equation for you, and I put in some multiple choice because these questions that you're going to be solving are all going to be multiple choice. Now, here we have our A, B, C, and D. Can anyone tell me which options are no good? We could just throw them away. They're not at all valid. Why D and C? Are they both too big? All right, so that's good. So y'all know that one of them is too big. So what's the range that our answer needs to be in? Our answer needs to be between two numbers. What are those numbers? Close. All right, the answer needs to be between 28 and 30. So if 90% of you are 15 and 10% of you are 16, our average needs to be between what two numbers? 15 and 16. Our average can't be 14.95. It just won't work. So we can go ahead and throw away answer choice A and answer choice D. Now, another thing we can do is we can look at our abundance. So 28, isotope 28 makes up 92% abundance. So our answer should be very close to what? It should be very close to 28. B is going to be the closest to the correct answer. That is not the correct answer, though. So what is the correct answer? What did y'all get? Three or eight? 8, and then that's just going to round to 28.11. Hands up if you got this answer. Hands up if you got something else. Okay, just a couple of y'all. All right, let's go ahead and move to the next one. Shh. We're going to move to the next one. And anyone who needs help on this one, I'll come around and help you out right now. All right, so this is the last example we're going to do before y'all start doing your assignment. 6 laps, and then we'll go over it. Okay, so let's go ahead and solve this one real quick. This one is just like the last one. So we got 46 times 8, close parentheses, plus 47 times 7.8, close parentheses, plus 48 times 73.4, close parentheses, plus 49 times 5.5, close parentheses, plus 50 times 5.3, close parentheses, and then all of this divided by 100. So what's the range for our answer in this one? Our answer has to be between what two numbers? 46 and 50. If it's outside that range, your answer is no good. Now, a majority of our isotope is going to be 48. So what should our answer be very close to? It should be very close to 48. So it could be under, it could be over, but it should be very close to 48. What's the answer that y'all got? 0.923? All right, so that sounds about right. Hands up if you got that answer. All right, I'll take it. Any questions on this assignment, or y'all got it? All right, let's go ahead and move on to the next thing real quick. So everybody get on Classroom. Let's go, Classroom. All right, so once you get in classroom, you're going to see the assignment that I posted. Okay, so once you get in classroom, you're going to see that this assignment is posted. This is Unit 4 of Positive Chemistry, so isotopes. And I got rid of most of it. So all I need y'all to do is the inquiry, vocabulary, atomic structure of isotopes, and the average atomic mass. So the order that I want y'all to do these is first, we're going to do the inquiry. After you're done with the inquiry, I want you to do the average atomic mass. Are y'all following? And the reason is those two things are going to make up 50% of your quiz. Well, actually, that and the atomic structure of isotopes. That makes up a majority of your quiz. So just make sure to do inquiry and average atomic mass, and then work out the other two. However, all four need to be done. Most people finished it before they left today. So let's go ahead and open up the lesson. Click on number 1. We should all be looking at the same thing, or a very similar thing. And then here at the top, you're going to see a link that opens up your simulation. So here's our simulation. Click on isotopes. It's the blue thing. Y'all don't see it? All right, won't let me split screen. All right. Shh. So let's go ahead and take a look at this one. So my isotope is boron. Your isotope might be something different. So I'm going to click on boron. There's my isotope of boron. And the first isotope they want me to pull up is boron 8. So boron 8 is going to have 5 protons and 3 neutrons. So I need to get rid of some neutrons. So now I have 5 protons and 3 neutrons. That's going to be boron 8. Click on abundance in nature. That's going to tell you how much of it is naturally occurring. Is this a stable or unstable isotope? Unstable. So over here for stability, we're going to put unstable. And then in nature, it's 0. Then we're going to make boron 9. Boron 9, we're just going to add a neutron. Also unstable, also 0%. So unstable, 0%. Next one is boron 10. So boron 10. This one just became stable, and then 19.9. So over here, we're going to put stable, 19.9. Then we're going to make boron 11. That's going to be also stable, and then 80.1. So stable, 80.1. Last one is boron 12. Does this one exist in nature? Yes or no? Is it stable? So we're going to put unstable and 0. Then when I hit check work, it should all go green for you. And well, you should be able to answer those on your own. I just wanted to show you how to do this top part. All right, so that's it. Let's go ahead and get it done. Good luck on your quiz next class period. I hope y'all ready for it.